Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to be going over how to write out the molecular orbital energy diagram for a few example molecules. So let's get into this. Okay, so the first question we have, or first problem, it says use a molecular orbital energy level diagram to predict the bond order in He2 2 plus ion. That's the helium molecule with a 2 plus charge in this, and then it asks the question, is this a stable species? So the first thing we need to do is we need to recognize that the two helium atoms have electrons that are in the 1s orbital. So only the 1s atomic orbitals are going to be involved in creating molecular orbitals. So we're going to start off by drawing our molecular orbital energy level diagram here. So here we have the 1s orbital from the helium, one helium. Here we have the 1s orbital from the other helium. So here and here. So these are the atomic orbitals. Those are going to combine together to give you the bonding orbital and the anti-bonding orbital. And so here we have the bonding orbital of sigma 1s, and we have the anti-bonding orbital of sigma 1s star. And so from the two atomic orbitals, we get two molecular orbitals. So now the next thing we need to do is fill in the diagram with the electrons, the valence electrons that are in our molecule. If you remember, if we start with hydrogen, or I'm sorry, if we start with just helium 2, then we would have two helium atoms, right? So if I erase the 2 plus here first, we know that helium has two valence electrons in the 1s. So both of these would have two valence electrons. So if we go spin up, spin down, this one would be spin up, spin down. So there's our separate helium atoms, and then if we're going to combine them into a molecule, then we would take the four valence electrons and fill them in to our molecular orbital energy level diagram, just like we would with any energy level diagram with 1s and 2s and 3p and all that stuff. So we're going to follow the Aufbau principle. We're going to start at low, work our way up to higher energy levels. We're going to use the Pauli exclusion principle, meaning that we're going to put two electrons into each orbital, and only two, and they're going to be both opposite spins, spin up, spin down. And then, of course, Hund's rule, if we have equal energy molecular orbitals, then we'll fill in each one at a time before pairing up. We don't have to worry about Hund's rule here because we don't have any molecular orbitals that have the same energy yet, but we'll get to that in a later video. Okay, so we have four electrons. If it was He2 helium 2 molecule, we would fill in spin up, spin down here, and then we would spin up, spin down here for the other two. And this would be our helium, and we saw before that the helium electron configuration for the molecular orbital diagram, for the molecule He2, that would be sigma 1s with two electrons, followed by the sigma 1s star, and that has two electrons. So that would be the electron configuration for the He2 molecule. However, if we do the bond order, if you remember, bond order is going to be the number of bonding electrons minus the number of anti-bonding electrons divided by 2. So here, the bond order is equal to 2 bonding electrons minus 2 anti-bonding electrons divided by 2, and then that's going to give us 0. Okay, so really this means that the bond order is 0. This means no bond is going to form. So this is not going to be a possible species. This is not stable. It's not going to come together. But let's go back to the one that we're being asked to. What about helium 2 plus ion? So here, that would be like if we're going to bond together 2 helium ions, 2 helium plus ions to form helium 2 plus. Okay, let me make that better. Let me make this a little bit better. So we have He2 2 plus molecular orbitals. And so in this case, since we're dealing with He plus, this doesn't have 2 electrons, it lost electrons, so it's going to be 1 electron. So here we're going to have 1 electron, and then the same thing with this helium ion, that's going to be 1 electron. So in this case, we're not going to have these 2 electrons here. So the 2 electrons are going to be put into the bottommost molecular orbital, the sigma 1s. And so given this, if we could write the electron configuration for He2 2 plus, that's going to be just 2 electrons in the sigma 1s. So it's going to look like this. So sigma 1s with 2 electrons. And the bond order is calculated the same way. So the bond order for this one is going to be equal to, we have the 2 electrons, bonding electrons, right? So it's going to be bonding electrons, which is 2, minus the anti-bonding electrons, but we don't have any anti-bonding electrons, so that's going to be 0. And we're going to divide that by 2. 2 divided by 2 gives us 1. So we would expect this to have a strong single bond. So this would be a single bond holding this together. So this is going to be a stable species because it's got a bond order of 1, meaning it has 1 bond between the 2 helium ions. So that's going to be a possible species. Okay, let's move on to the next example problem. Okay, let's start with the second problem here. So the second problem here is we're asked to use a molecular orbital energy level diagram to predict the valence electron configuration and bond order of the H2 2 minus ion. Is this a stable species? So this is very similar to the previous problem we just did. Instead of helium, we're dealing with hydrogen. And this time we got hydrogen with a negative charge. So we want to get the information regarding the H2 2 minus ion. So this is like we're taking one H minus ion and putting that together with another H minus ion. So each of these, again, is going to involve the 1s orbital. So we have our molecular orbital energy level diagram here. We have the 1s orbitals on the outside for each of the atoms. And since hydrogen has a minus charge, that indicates that hydrogen here, this ion, the H minus, has 2 electrons because there's 1 proton in the nucleus. So in order to get the negative charge, you'd have to have 2 electrons in the atom. So this has 2 electrons, and this one has 2 electrons. So now that we have the valence electrons filled in for the atomic orbitals, we can take them and fill in the molecular orbitals according to the same rules, right? Aufbau principle, Pauli exclusion principle, Hund's rule. So we're going to start with the lowest energy possible. We're going to fill that in with 2 electrons. We got 4 electrons total. We used 2, now we have 2 left. So since this is full, because of the due to the according to the Pauli exclusion principle, we're going to have to move up to the next higher one and start to fill that in. We have 2 electrons left, so those 2 are going to go into this one here. So now we have our orbital energy level, molecular orbital energy level diagram filled in. So now we can get the valence electron configuration for the molecule, for the H2 2 minus molecule. So that's going to be, let me write it up here, H2 2 minus. And we're going to start at lowest level. So we're going to start here, and it's going to be the sigma 1s. Oops. Sigma 1s, 2 with 2 electrons, and then we go to the next one, which is going to be the sigma 1s star. So sigma 1s star, and that has 2 electrons in it. So this is the electron configuration for the ion H22 minus. So now, what about the bond order? Well, we're going to calculate that. So again, the bond order is going to be equal to the number of bonding electrons minus the number of anti-bonding electrons, all divided by 2. So you're going to find the difference between bonding and anti-bonding electrons and divide that by 2. So we have 2 bonding electrons in the sigma 1s. So that's 2. And we have 2 electrons in the anti-bonding sigma 1s star. So we're going to subtract out 2. And then we're going to divide that by 2. Well, 2 minus 2 is 0. Divide that by 2, you get 0. So the bond order is 0, meaning no bonds form. This is not going to be stable. So the answer to the question, is this a stable species? Is H2 2 minus stable? No. It's not going to be stable. It's not going to form a species here. These 2 ions are not going to form a bond because that is mainly because of the destabilizing anti-bonding electrons. That makes it unstable. So it's not going to form a molecule. And that's it for this video. Those are a couple of good example problems. If you enjoyed this video, if this helped you in any way, then please by all means like the video, share the video, hit that like button somewhere over here, somewhere. You can find it. I believe in you. Also, do me a favor, subscribe to the channel, hit that notification bell. When you do, click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, put it down below. If you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.